All right, hello everyone.
Hi.
Hi. My name is Samantha Bobra. I'm super stoked to be here at droidcon, and I'm really excited to present Beyond the REST API, gRPC for Android. The goal of my talk today is to help you understand what gRPC is, when you would use it, what it's good for, how my company uses it, and how you can build your own gRPC client on Android. So if you're not interested in learning those things, you can just leave now. All right, let's start off with who I am. I've been an Android developer for about 5 years, and for the 4 most recent years of that, I've been working on an Android app at VSCO that's used by millions of people every day. I'm going to talk about VSCO a little bit because it's part of our story today. VSCO is an art and technology company that empowers creative expression around the world. Most people know us for our photography app that lets you take photos, edit them, and upload them to our community of artists, photographers, and other creative people. I started out at VSCO working on the Android app, but recently, in the past couple of years, I've also become interested in our backend. It was something I didn't know a lot about, so it's been a cool transition. I've been learning a lot, and it's been really fun to work across the stack and have the fun experience of wanting to blame somebody on the back-end team for something that's going wrong and then realizing that that person is actually me. So when I was transitioning to doing more web development, I started learning about gRPC. This was a technology that we were already using at VSCO for communication between our microservices, but we weren't yet using for communication between our server and our clients. So at this point, I'd like to know a little bit about the audience. So who has actually used gRPC before? Nice, okay. Who thinks they haven't used it, but you have a pretty good idea of what it is? Okay. And who doesn't know that much about gRPC and is just curious? Okay, nice. So I want to tell you what gRPC is, but I'm not going to do that right away. In order to explain it, first I'm going to tell you a story of when we started using gRPC on the mobile clients at VSCO. So it actually starts with this guy. His name is Cantor. He's a German mathematician who came up with set theory, and he kind of, through a weird story, is who we ended up naming our in-house analytics platform after. So in the past, before we built Cantor, VSCO used a variety of external data services to log our metrics, but we got to a point where the company was too big, so it was time for us to build our own solution. So in our app, every time a user takes an action, we have to track it and then feed it into our own data pipeline. So we were figuring out what this would look like on the clients. So before we built our own solution, this is what our code looked like. It actually still kind of looks like this today. This would be a user visiting the profile of another user, and we would track an event to log that. So the thing about this is we have a pretty complicated app, and there are a lot of different things that you can do in it. In fact, there are 152 different distinct actions that a user can take, and each of these actions has its own fields and parameters that are applied to it. So say when you edit a photo using VSCO, you would apply a preset to the photo and also be able to change things like contrast and saturation and shadows and highlights. So if we're logging an event for a user editing an image, we'd want to record this information. But say a user is viewing another user's profile, instead we might want to track something like the user ID of the profile that they're viewing and maybe a reference of where they came from, how they found that profile. So for every event it's different. So there are a lot of events that we had to track, and we also had to upload these events very often, like periodically on a timer, and sometimes these would be large payloads, and we want to make sure that we can do this quickly. So originally we had a few pain points with this. One of our biggest problems was with consistency. So at VSCO we have an Android app, an iOS app, and also a desktop website. Behind the scenes, each event and their properties would get transformed into a hash map, and then we would upload it to our various different metric services. So in this example, say a user views another user's profile, we'd want to track their user ID and also whether or not they were referred there from one of VSCO's suggestions for them. So you can see for the first app, the Android app, we have the event name, we have a user ID, which is a long, and we have this referred from suggestion Boolean field, which is true. If you look at what the iOS team implemented, the event is the event name, we got that right. But now the user ID, the field user ID is kind of different. It's now also a string instead of a long. And instead of referred from suggestion, it says referrer from suggestion, which is not right. And then when you go to the desktop website, it's even more messed up. We just completely forgot to log the user ID. And now the Boolean is a string. So you think, even though we had a wiki page where we were supposed to be keeping track of this stuff, we still managed to mess it up pretty often, which would actually result in a lot of weird data, a lot of inaccurate data, and just wasn't very dependable. It just gave us strange results that were hard to track down and hard to just stay on top of all the changes that we were making. So we came up with some really weird solutions to try and fix this problem. One of them was we made this giant JSON file that had JSON representations of all the events. And every time we'd log an event in the app, we'd compare our hash map against this JSON file and try and validate that we were sending up the right fields with the right names. But this still didn't really fix our problems. People would just neglect to update this file, or people would make mistakes in the file itself when they were writing it, or people would get so far behind on updating things, they maybe wouldn't update the metrics for a month, so they just kind of ignore it and just copy and paste stuff. And it just also wasn't really fixing our problems. So this is where gRPC came in. Like I said, VSCO had already been using this technology for a while on our backend, and it had been a positive experience for us. So we decided that this would be a good first use case to try and use gRPC for communication between the clients, the mobile clients, and the server. So gRPC is a framework for communicating between a client and a server. In order to understand how this is different from what you're already doing, because I'm sure all of you are Android developers, all of you have an app that probably has a server, you're probably communicating with it. In order to understand how this is different, I'm going to talk about what you probably do currently use right now, which is REST, or maybe just an HTTP API. This is very widely used. You're all familiar with it. It consists of making a request to a URL over HTTP. You attach some parameters or some body to your request, and you get a response in the format of XML, JSON, HTML, or any number of different formats. There's a popular library for Android called Retrofit. The code might kind of look something like this. A lot of people use it because it helps simplify the raw code that they'd have to write without using a library. And in this case, we're just making a GET request to a URL, and the object that we have here is the plain Java object that we're parsing our response into. So probably a lot of you use this, looks familiar. In REST, every API call you make will fall into one of these 5 categories. The GET request is for reading information from the server, the POST is for creating, PUT is for update or replacing, patch is for modifying, and delete is for removing. So maybe in your API you use all of these, or maybe you use just a few of them. Maybe it's not really a REST API, it's just an HTTP API, and you maybe just use GET and POST, but probably you're using something that looks like this. So if this is something you're all using, and it all is kind of working for you, what's wrong with it? Well, one answer to always keep in mind about this is maybe nothing. If REST is something that's working for you, if you're not having problems with it, no pain points, it's fine, it's good enough, then I would never tell you to stop using something that is working for you. But if you do have some pain points with it, I can tell you about what some of ours were. One is that sometimes those 5 verbs are not really sufficient to describe your entire API. Code can get really complex, so sometimes it's really hard to fit everything into one of these 5 categories. It can feel kind of unnatural, a little bit limiting. Another point is that you have to write a lot of code. It doesn't really feel like probably to you that you have to write a lot of code, but even if you're using something like Retrofit to help you out, you still have to write the Java objects that your JSON gets deserialized to. You still have to write some layers of code around your Retrofit code just to get it in a place where you can work with it. You still have to do a lot of setup for it, and that's your responsibility to write that code. Next, you have to agree outside of your app in a way that's not enforced by the code at all, some kind of contract between your client and your server. So this might be like a wiki page, it might just be you talking to your backend team, but The front end is going to expect some sort of response from the back end, and if they don't get exactly that response, your app can crash or might not behave the way it's supposed to. And the server is also going to expect some sort of request from the client, and you need to send those exact fields, otherwise things might not work properly. And this is something you just have to agree on. Next, JSON serialization is pretty slow. JSON is a text-based format, and especially on Java, serializing and deserializing JSON can be costly. And lastly, depending on how you set up your backend, you might still be using HTTP version 1.x, which is generally less performant than its successor, HTTP 2. If you're using HTTP 2 already, great for you, but a lot of people aren't. So now it's finally time to talk about what gRPC is and what it can do for us. In order to explain it, first I have to talk about what RPC is. You might remember this just from your experience or maybe from like computer science class, but RPC is a network communication protocol. On the surface, it looks like when you're making an RPC call that you're calling a method or a function locally on your machine just like you'd make any other method call. So the code I have there is an example of an RPC call. However, instead of this function being executed locally, it's actually being executed on a remote machine. And this is done through a stub or a proxy that lives on the client, which handles the networking logic behind the call and makes a nice interface where it looks like it's local, but it's not. It works exactly the way, a similar way to non-RPC calls work, so there's a request and a response. Now we're going to go back to gRPC. gRPC is a performance-focused open-source RPC framework developed by Google. It was originally based on an internal tool called Stubby at Google and was released externally as gRPC in 2015. gRPC is most commonly used for communication between microservices on the back end. It's used by a lot of companies, by Netflix, Square, obviously Google, Lyft, VSCO. It comes with client libraries in 10 different languages, and actually more. There's some rudimentary support for some other ones as well. And it uses HTTP2 based transport, which I'll talk a little bit more about later. But basically what it looks like in this diagram is that there's a gRPC server that lives on your service. And you can have as many clients as you want that have a gRPC stub living on them, where you can make a request to the server and receive a response. The client and the server can be written in different languages. To start off with, let's talk about the most basic building block of gRPC, which is the protobuf, or protocol buffer. Protobufs are the IDL, or interface definition language, that gRPC uses. Protobuf messages themselves are a serialization format, so similar to something like XML or JSON that you're already familiar with. The idea is that the .proto file is kind of like a blueprint. So from this very simple definition file, you will compile the file and code will be generated from it in whatever language you plan to use. It can be generated in a number of different languages, and for each language there are also different code generation libraries, so you can pick the one that generates code that is the best fit for you. So these are the languages that's supported by protobufs. Like I said, there's rudimentary support for other languages. These are the ones that have full support, but I know our team has gotten it working in Swift. I've heard some things about Kotlin, but Java is definitely fully supported. What's really valuable about protobufs is that they're a binary format. Binary formats use space more efficiently than text-based formats like JSON, making them smaller and faster. And the specific encoding for protobufs also packs more data into a smaller number of bytes, so it's faster across the wire. And the human-readable version of the proto file that I'm about to show you is just for usability, it's just for readability. It's not the actual text that's going to be sent over the wire. So Google claims that it can be 3 to 10 times smaller than XML and also 20 to 100 times faster than XML. I'm not really sure where these benchmarks are coming from exactly, but a lot of people have tried to benchmark it themselves. Here are some examples of benchmarks. The graphs on the left are actually from C# data, and they benchmark the data sizes for XML versus JSON versus protobufs. And in Java, I would actually expect this distinction to be even more dramatic. The graphs on the right are some Java speed benchmarks for serialization of JSON versus protobuf. So you can see that this is actually a pretty dramatic difference. Here's what the actual protofile looks like. What a protofile acts as is a contract between the client and the server that's actually enforced by the code. So from this one file, your entire service with the server networking code, along with the client networking code, the RPC methods, and the request response messages are all going to be generated and defined by this file. So the client and the server will both share a copy of this file. The same file is present on both, and you can generate code in different languages on the client and the server, but this is the common file between them. So it's also nice because you can look at it and just get a high-level overview of what the service is and what the code is doing. I'd like to take a minute right now to say that gRPC and protobufs are not the same thing. They can exist separate from one another, or protobufs can exist separate from gRPC. gRPC just uses protobufs as the message interchange format, but again, you can use protobufs alone or with some other RPC library if you want. Let's break down what's going on in this file. First, there's a service definition. We're defining our service. It's called greeter. And the greeter service has one method in it called sayHello that takes in a request and returns a response. The client will call this method to interact with the server. So next, we're going to look at the request. Hello request has a single field in it called name. This is the information that we want to send to the server. For name, we could define the type, and also a name for the field, which is name in this case. And we have to assign it a value. In this case, it's going to be 1. If we add other fields, they'll just be 2, 3, and incrementing after that. And in this case, name is a string, but it could also be an int. It could be a float. It could just be bytes, or it could be even another message type that we could define. So this is a very simple example, but it can get a lot more complex depending on your needs. So let's also take a look at, so if we add the repeated keyword, we can, the code that will be generated will be an array, or depending on what language you're using, whatever is the equivalent of an array. So in this case, we've added the repeated keyword, and now we've named it names instead, and this will let us attach an array to our protobuf. Okay, now we're going to look at the reply, which is the response that we're getting from the server. Looks pretty similar to the request. In the reply, we're going to get back a string message. So the stuff at the top of the file, we'll go through it. The first line is just defining which syntax we're going to be using, Proto 3 as opposed to Proto 2 or something earlier. The next options are all for the generated code. So Java multiple files is true. This will just say that for each class that we generate, we want it to live in its own file. So the next one, Java package, this will let us say what the package name of the generated code we want to be. And the last one, this is really more relevant if you're not creating multiple files, but this will define the outer class name for your files. And then lastly, we have the Protobuf package, which we're calling Hello World. This will stop us from having collisions if we decide to add other protofiles in other packages. So now that we've defined this protofile, it's time to actually generate the code. The most simple bare bones way to do this is using a tool called protoc. This is a command, well, in this example I have on the screen, this is the command line tool. So you give it the source directory and the name of the protofile, and then give it a destination directory for where you want it to generate the code. And if you run this, it will generate your protobuf code. So what's important to know about this is this won't actually generate the gRPC related code, so the actual server and the client stubs. For that, you need a special gRPC plugin, which I'll show you later how you can incorporate that into your Gradle build. But this will generate just the messages, so the request and the response. But assuming that we are able to generate the server, the client, the request, and the response, which we'll know how to do later, here's just an example of what the generated code looks like. This is the code generated for the request. The important part to notice is that it uses the builder pattern pretty liberally. You'll see the builder pattern all over the generated code for gRPC and Protobufs. There's a getter and a setter that's generated for you, makes it kind of easy, and a bunch of methods that you probably won't use, but you could if you wanted to. The response is going to look pretty similar, so here's an example of what the stub looks like. The stub is what hides all of the networking code behind the scenes, and all of it is generated for you, and the only method we really care about is the say hello method, which takes in a request and then returns a response observer, which is kind of like a listener. So how do we actually use this generated code to make an API call? I'll go through this line by line, but this is all the code that you would need in order to make a call to your server. Starting at the top, first we have to create a gRPC channel for our client. We create a managed channel using the builder pattern. We're going to give it an address, which in our case would be visco.co/API/something. We give it a port number. And in this case, just because we're testing, we're saying use plain text is true. Generally, by default, a secure connection like TLS would be used, but in this case, we're just testing, so we don't really need it to be encrypted or anything like that. Next, we use the managed channel to build a stub. The stub contains all of the networking code. You pass in the channel, it does everything for you. So next we build the request, again, using the builder pattern. We're going to call setName and give it a string for the name field. And now this is the part where we actually make the API call. So you can see we're using the stub to call say hello. We're passing in the request, and we're also passing in a stream observer. In this case, there are going to be 3 callbacks. So one is on next, that indicates a success. Then there's on error, which indicates an error. And then on completed, which indicates that it has completed regardless of success or failure. In this case, this is actually going to be an asynchronous call. And if we decided that we didn't want it to be an asynchronous call, all of that code is already built into the generated code. If you want to use your own method of creating an async call, I know a lot of people have various different ways they like to do that. You can instead use a blocking stub. This does exactly what it seems like it does, which is block. And you can wrap it in whatever your favorite method is. You can also use the future stub, which returns a future, if that's what you prefer. All right, so all of this looks nice. It's nice to not write code. Everyone likes that. But why is it better? What are the performance optimizations that actually make this better? The main one is that it's faster. Protobufs, like I mentioned, are highly efficient over the wire. gRPC also uses static paths for call dispatch. So instead of a path being something like get user /1234556, you would just call get user and pass in a parameter, which means that it doesn't have to parse this out. There's also no need to compress JSON, no need to parse JSON, no parsing long paths, query parameters, payloads. It doesn't have to worry about any of that. What's also nice about gRPC is that you get multiple connection options. So the example that I just showed you, that's an example of a unary call. So that's just giving the client makes a request and gets a reply from the server. But you can also do streaming really, really easily with gRPC. So you can do server-side streaming, which is when the server streams to the client a stream of messages, and the client will read from the stream until the stream is finished. You can do it the other way, where the client will stream to the server, and the server will continue reading the messages until it's finished. Or you could do both at the same time, have the client and server streaming to each other in whatever order you would like. This sort of thing is ideal for creating a chat app, for example, or large uploads or downloads. And gRPC makes it really, really easy. It generates code for you to do this easily. There are a couple of other benefits. Some of them are sort of more on the back end, so maybe not super relevant for a mobile developer, but it allows you to do call tracing and cancellation. So because there's a gRPC context that's passed through an entire system, if you're using gRPC across multiple services, it makes it really easy to trace your call through your whole system, and it also makes it easy to cancel a request that's already in flight. And lastly, gRPC uses HTTP2 by default, which is the latest version of HTTP. And I'll talk about that a little bit. Let's talk about what the changes are from the earlier versions. So one is that HTTP2 is a binary protocol, meaning that it's, like I described before with protobufs, it means that it's more efficient, more compact, and also less error prone. It lets you do request multiplexing, which is pretty cool. It means that with HTTP2, you can send multiple requests for data in parallel over a single TCP connection, instead of having to open a new connection. In the old way, sometimes things could get backed up, or you'd have to create multiple connections. But in this case, it's a lot better at parallelization, and you can send multiple requests in quick succession over the same connection. HTTP2 is also faster without you really having to do anything. It has some features like reduced round-trip time just out of the box, header compression to reduce overhead, faster encrypted connections, and all the weird optimizations that people used to do to try and get around limitations of HTTP, like sprite sheets or domain sharding or any other little tricks. All of that stuff is not necessary anymore with HTTP2. It also has better prioritization for requests from the client. The client can prioritize the requests. And it also allows you to do server push, meaning that the server can push information to the client without the client having to request any information. Okay, so now that I've showed you the code, let's talk about how you can build a client on your Android app specifically. I'm about to put a lot of code on the screen, so don't be scared by it, but we'll go over it step by step. So starting at the top, this is my build.gradle for a very simple gRPC client project that I just whipped up. This is the entire build.gradle, but I'll talk about the specific changes that I had to make to allow protobufs and gRPC to work. So starting at the top, we're going to use something called the Protobuf Gradle plugin. What this will do is whenever Gradle runs, if you include the proto file with your Android application, it will generate Java code from that proto file when you run Gradle, which is really nice. So here in this place, we are specifying that we want to use the Protobuf Gradle plugin, and we're going to be downloading it from Maven. All right, next, we are going to be adding some new dependencies for Protobuf and for gRPC. The first one is the Protobuf Lite dependency. So what this means is, like I mentioned before, even though we're using Java for protobufs, there are different code generation libraries that we can use for it. The default one is called Java, but there is one called Lite, which is specifically designed for Android applications. There's some changes, but the major one is that it's just less code. It's more compact, so it doesn't take up as much space in your APK. And it also just kind of looks more Android-y. The patterns are something that look more like what you would use as an Android developer. There are also a few other ones. There's one by Square called Wire. There's one called Nano, which isn't really used that much anymore. Lite is the one that they recommend that you use for your Android app, so it's a good place to start. The next one is gRPC stub. This is the library for generating the gRPC client. If you were generating the server, you would use a different dependency called something like gRPC server, but this is saying that we just want the client code. The server code is like somebody else's problem and might not even be written in Java. It might be a different language, so we don't need it in our application. Next is an OkHttp dependency. gRPC on Android using this plugin is backed by OkHttp, so we add that dependency. And lastly, we have to add a dependency specifically for gRPC using Protobuf Lite. And there's a little note that you have to exclude this Protobuf Lite module from this dependency because it's already added in a previous dependency, and you'll get an error about the duplication. All right, next we're going to add our proto file to our Android application. We're going to put it in this proto directory, which is a source directory that lives alongside our Java directory. And this is customizable just like any other sources. You can change the name of it, you can add different source directories, you can have multiple proto files, whatever you want. I just have an example of the source sets block where you can change it. And lastly, we have to add this protobuf block to our build.gradle. So I'm going to start at the beginning and break down what's going on. So first we have to define this Protalk plugin. We have to define where Protalk is coming from, and this says that we're going to download it. If you want to use your own version of Protalk that is local, you can do that too. Next, we're going to define plugins for code generation. So we have our Java Lite plugin and our gRPC plugin. This doesn't actually apply the plugins, we're just defining them. And like I said, you can always use a different plugin, like one for Wire, or we actually built our own plugin because the code that was generated was missing some stuff that we wanted. So we built our own plugin, and this is where you would define it also. The next line is specifying where the files will be generated to. In this case, it's going to go into the generated directory in our source folder, but we can move this, we can change this wherever you want. And then lastly, the Protobuf plugin will generate a task for the Protalk run. So here we're telling it which plugins to apply. So we're saying the Java Lite plugin and the gRPC plugin. If you don't add this here, they won't actually be applied. And we're adding the Lite option for gRPC also, which will do the same thing as it would for the Protobufs. So if you do all of what I described above, you're kind of ready to go. You can use this code that I showed you before in your Android application. Everyone's build is different, so you might have to do some different configuration for your specific use case. Obviously, most of your Android apps are going to be more complicated than just a simple demo app. And I know for us, we put all of our networking code in a separate module, so we had to make some adjustments for that. But overall, that's kind of mainly the only changes you need to make. And the last recommendation I have is that you have to make sure that you're updating your proto file. So because the proto file is shared between the client and the server, whenever somebody makes a change, we have to make sure that we're updating it in our app so that the code gets generated using the new version. So I'd recommend using maybe a Git submodule to pull in the proto file and have that live in a separate repository, or maybe some sort of update script to update it in your app. But it is important to make sure that you're updating it regularly whenever you make changes to it. All right, so what are some downsides of gRPC? There are a couple. One is that you might have noticed that this isn't something that you can implement on your own as a front-end developer. You have to work with your back-end team as well. Hopefully you'll be able to advocate for it now if you think that it's something that will help you, and you can also use it in your personal projects. It makes it really, really easy to set up a server, like very simple, because the code is all generated for you, and you can use whatever language you're comfortable with. But it is something that you have to agree with your backend team on. Another issue is that gRPC support isn't universal. There are sort of some a limited subset of languages, although it does cover a lot of the most common ones that are supported. And also the load balancer support was previously not great. Now Lyft came up with Envoy, which has helped us a lot. We use that. But again, the support might be somewhat limited, depending on your needs. Next, the generated code might not meet your needs. It's really nice if you just kind of don't have very specific things that you want out of the generated code, just kind of getters and setters. But if you have something complicated that you're doing, it might kind of feel like it doesn't give you everything you want. In our case, like I said, we built our own code generation plugin for our build.gradle, but that's up to you. And lastly, there's not really a curl tool to test this the same way that you would test, say, a REST API endpoint. If you want to test the server, you sort of have to just build like a little mini client or some other kind of like hack. But what's good about that is it's pretty easy to do. So, in conclusion, gRPC does come with some downsides, but it's been working out for us so far. So I hope that you now feel educated enough to decide whether it will work for you or your organization. And even if you're not going to use it for communication between your mobile clients and your server, it's very useful for communication between your backend services. So that's also something to keep in mind. That's been working out for us really well. If you want to learn more, here are some of the most common resources. There's the gRPC website, there's the GitHub repo for gRPC Java specifically, there's the Protobuf website, and there's also the repo for the Protobuf Gradle plugin. And that's about it. You can find me on the internet if you want. I'm Sam Writes Code. If you want to learn more about VSCO or get the app, or we're also hiring Android developers, you can check us out. Shout out to my team. And if you have any questions, please come up and talk to me after the talk. I'll be here for the next, I guess, 15 minutes or so. Yeah, hit me up. Thank you.